Welcome to the Layer 3 EVPN section. Layer 3 EVPN can be configured as asymmetric or as symmetric. Before we configure Layer 3 EVPN, we also need to have mach-VRF instances configured on our leaves. In a Layer 3 EVPN asymmetric configuration, we should have all of the mach-VRFs mirrored to each leaf, even if we don't have any physical servers connected on each mach-VRF instance. We will have IRB interfaces, which can be configured with different IPs, as you can see here, or we can configure the IRB interfaces as anycast gateways, which means that for each mach-VRF instance, either it is on leaf 1 or on leaf 2, will have the same gateway IP address. So for mach-VRF 1, we'll have 192.168.10.254 on both leaf 1 and leaf 2. And for mach-VRF 2, we'll have 192.168.20.254 on both mach-VRF 2 on leaf 1 and mach-VRF 2 on leaf 2. IRB interfaces are binded to a common IPVRF instance, and they will also be configured in each of the mach-VRF instances. And the same is valid for leaf 1 and leaf 2. The VXLAN tunnels will be installed only between the mach-VRF instances which are sharing the same VNI. We'll have multi-protocol BGP enabled with EVPN between each mach-VRF instance. We will use the System 0 interfaces on each leaf to install the VTAPs and to establish the BGP configuration and to establish the BGP peering. So when the server in VNI 10 will try to reach the server in VNI 20, traffic will first go to the mach-VRF 1 instance where the host is connected. Then, using the IRB1 interface, traffic will go to the IPVRF instance. From here, we'll have the IRB interfaces from mach-VRF 1 and mach-VRF 2, and basically this instance will perform router on a stick, and the traffic will be sent to the mach-VRF 2 instance. Using the VXLAN tunnel between mach-VRF 2 on leaf 1 and mach-VRF 2 on leaf 2, the traffic will be sent on leaf 2 mach-VRF 2 instance, where it will be decapsulated from the VXLAN information and it will be sent directly to server in the VNI 20. This solution is called asymmetric because when server in VNI 10 will want to reach server in VNI 20, the traffic will flow from one mach-VRF instance to the IPVRF, after that to the mach-VRF 2, and only after that it will go to its destination on leaf 2. This solution is easy to configure and it looks simple at the first glance. But if you have a large environment, this configuration is not so great because it's not easy scalable and it will require a lot of config overhead, mainly because all mach-VRF instances need to be replicated across all leaf devices. So, server in VNI 10 will try to ping server in VNI 20. As mentioned, traffic will reach mach-VRF 1, and since the destination is in a different subnet, traffic will be sent to the IRB interface, which can communicate to IPVRF instance. And IPVRF instance is a layer 3 instance. In the IPVRF instance, we'll have a route, and the best matching route will be selected from the IPVRF routing table. And just like that, traffic will be sent to the mach-VRF 2 instance, where we'll have an VXLAN tunnel installed between leaf 1 and leaf 2. And as you can see, this is the bridge table entry found on leaf 1. As the traffic will arrive leaf 2 on mach-VRF 2, the bridge table of mach-VRF 2 will be consulted and will find an entry which will match the server in VNI 20. And the return path will follow the reverse path as explained above, meaning that it will go to MAC-VRF2, then to IPVRF, then to MAC-VRF1, and after that straight to MAC-VRF1 on leaf 1, and only after that to the server in VNI 10. So let's go ahead and see layer 3 asymmetric implementation in action. I will ping PC2, which is connected to leaf 2, and it is in a different VNI. As you can see, my PC is in VNI 10, and I will ping the PC in VNI 20. As you can see, the ping works, and if you go ahead and check the network instance, v10, bridge table, MAC table, all. Let's check the MAC address of PC2, which is 666803. We will not find this entry in our MAC table, but we will find the IRB interface MAC address. Since the IRB interface is configured as a default gateway, our traffic will be sent from the MAC-VRF instance to the IPVRF instance. So show network instance L3 asymmetric route table all. The traffic will reach this route table, more precisely this layer 3 instance, and we will have a route which will be the best match for our destination IP address, which means that the traffic will be sent using the IRB interface assigned to VNI 20. So we will check the V20 instance, and we will find the MAC address, our destination MAC address, in this bridge table. Also, it can be reached via VXLAN 0.20 interface, and the VTAP of the endpoint is 22.22.22.22 in VNI 20. So traffic will be transferred to leaf 2, and on leaf 2, if we'll check show network instance V20 bridge table, MAC table, all, we will see our entry right here. The traffic will exit this interface and go straight to our destination host. What we can also do is show network instance default, protocols BGP, route EVPN, route type 2, detail. And if we find the route with our MAC address listed, we can find the ESI, also the VNI. We can find the BGP next hop. We can find the target, and that it is encapsulated in VXLAN. So because of this target that we have also configured on our network instance, the route will be propagated into the network instance with the same target configured. What we can also see is show tunnel interface VXLAN 0, VXLAN interface 20, and we can go with detail. And we can also see the VXLAN 0.20 information. We can see the VTAP source IP. We can see the VNI. And if you check on this end, show tunnel interface VXLAN 0 subinterface. And we can see the source IP address, the VNI and that it is a type bridged interface. We can also view all VXLAN tunnels installed, and we have just one VXLAN tunnel installed with leaf 1, and we can filter using the VTAP information. Upon checking the configuration on leaf 1, we can see that we'll have VXLAN interfaces for both VNI 10 and for VNI 20, and both of them are configured as bridged. We also have IRB interfaces configured as Anycast gateways, meaning that they can be the same on both leaves. In this type of implementation, we'll have to teach the IRB interface on how to treat ARP. If we will not configure this, the implementation will simply not work because the device will not know what to do with ARP. If we check the network instances configuration, we have a separated network instance for VLAN 20 and a separated network instance for VLAN 10. We'll have our route target configured, and it will be the same for leaf 1 and leaf 2. This is also valid for the VLAN 10 route targets. We'll have each of the VXLAN interfaces added in each of the network instances. We'll have our BGP EVPN configuration with the EVI, and because we have 2 spines, we'll have ECMP of 2 configured. We'll also have our physical interface added for VLAN 10. As you can see here, we have a physical interface to the MAC-VRF1. And if we check our layer 3 instance, it is pretty simple. It's defined as an IPVRF instance, and we'll have our 2 IRB interfaces belonging to VNI 10 and respectively 20. On leaf 2, the configuration is almost the same, with the exception that in this case we'll have our physical interface assigned to VNI 20 network instance, and the rest of the configuration is the same.